Open your phone right now, and you might see headlines screaming that a planet-sized asteroid has a 72% chance of colliding with Earth in 2038. This threat level has prompted global space chiefs to warn that we could eventually face extinction, pointing to Mars as our only viable alternative if we cannot protect our own world. These warnings are punctuated by the real-world existence of Apophis, a 1,000-foot-wide city-killer asteroid scheduled to pass within just 30,000 kilometers of Earth in 2029. But the viral headlines about a 2038 strike are fake. That 72% probability is an imaginary variable created by NASA and the UN for a hypothetical tabletop exercise. While the 2038 threat isn't real, the simulation itself is significant. Over 100 global experts gathered to model this exact disaster because they take the possibility of a future impact incredibly seriously. Earth's vulnerability is a matter of historical record. 66 million years ago, an asteroid strike triggered a mass extinction event that ended the age of the dinosaurs. Modern history proves these risks haven't disappeared. In 2013, a 20-meter meteor exploded over Chelyabinsk, Russia, with the energy of nearly 30 Hiroshima bombs. That single event injured 1,500 people and damaged thousands of buildings. Most importantly, it arrived with no warning from any existing planetary defense network. NASA conducted this 2038 simulation to stress test our international response. The goal is to determine if our current detection systems and disaster management plans are actually ready for a real-world alert. The first step is identifying the object. Most threats are rocky asteroids found between Mars and Jupiter. Comets are more volatile. Called dirty snowballs, they originate in the Kuiper Belt, far beyond our inner telescopes. Comets represent a higher danger level. Traveling at twice the speed of an asteroid, they leave us a significantly shorter window for a deflection mission. Knowing an object's speed and what it's made of allows space agencies to trigger the specific defense protocol required to move it. To find these objects before they find us, humanity has built a multi-layered surveillance network designed to spot threats decades in advance. The heavy lifters are programs like Linear and the Catalina Sky Survey. These projects scan the sky nightly, discovering thousands of near-Earth objects every year. In Hawaii, systems like Pan-STARRS and Atlas act as the final alarm. Using massive 1.4 billion pixel cameras, they scan the visible sky twice every night to catch anything missed. Every discovery is cataloged on the ESA risk list. Here, scientists use orbital mechanics to mathematically track any object that has even a fractional chance of hitting Earth. We are no longer blind to the rocks surrounding our planet. This network gives us the ability to track minute orbital changes years before they become a danger to a city. Once a threat is confirmed, the mock test moves into the counterattack phase. Using nuclear explosives is generally considered a last resort. Beyond the legal hurdles, the explosion can shatter an asteroid into thousands of radioactive pieces that could still impact Earth. A controlled method is the slow push. A spacecraft uses a solar beam to vaporize part of the asteroid's surface. This venting gas creates thrust. Applying this pressure over years gradually nudges the asteroid into a safe orbit. The most effective tool we've actually tested is the kinetic method. In 2022, NASA's DART mission successfully crashed a spacecraft into this asteroid, Dimorphos, at 14,000 miles per hour. That impact successfully shortened the asteroid's orbit by 32 minutes. It proved that we have the technical capability to physically deflect an incoming object by delivering a precise kinetic strike. The results of the 2038 simulation were encouraging. Over 80% of the participants concluded that our current technology and international coordination are sufficient to handle a major threat. Returning to the real-world threat of Apophis in 2029, the data is even more reassuring. Detailed observations have confirmed a 0% chance of collision for the next century, leading NASA to officially remove it from the risk list. Currently, there are no known asteroid threats with a significant chance of hitting Earth for at least the next 100 years. While viral headlines sell panic, the reality is that between our advanced tracking and proven deflection technology, Earth is more secure than it has ever been in human history.